start. Is voice clear? Voice is clear? Little fast answer. Voice okay. Now, see, previous class, I'll give previous, not briefly I'll tell. See, rectangle section. Red color required. Where is red color? 1 minute. Here. See, I told this, I think visible from there. What I wrote visible. See, this is S1. Just check it here. Okay. S1. This is S2. Rectangle section. This I given axis 1, 1. Axis 1, 1. Axis 2, 2. Now, once again I'll put one more sketch. Identical sketch I'll put here, once again. See. Same dimensions, once again, other things are same. This is 2, 2. This is 1, 1. Only axial force. One case, axial force is along this line, see. Or load, I'll tell load actually. Axial load, just load I'll put. Load P along 1, 1. Load P along 1, 1. 1, 1. Here, load P along 2, 2. Now further I am not explaining. Along 1, 1, see. This is fully S1. Oh, I need little space here. Okay, I want here. I write here. Load P along 1, 1. Along. Now, what you do is, this S, total S, divide into 3 parts. I'll divide here, first of all. See, this is S by S1 by 2, S1 by 2. Divide into 3 parts. See. S1 by 3, S1 by 3, S1 by 3. Total is S. So, somewhere here, see, this point here, anywhere along this line, see, on this line, this is your, you can write here, middle 1/3 length, see, this S1 by 3 is middle 1/3. Middle 1/3, or from center 1, 6, 1, 6. Load is anywhere on this line, or here. This is, see, this is your S2. S2. Divide S2 into 3 parts. S2 by 3, S2 by 3, S2 by 3. And this is your middle 1/3. Middle 1/3. Middle 1/3. Visible fully? Or shall I have to slightly lift actually? Okay, 1 minute. I slightly lift the camera. I think slightly not coming, I think. I slightly lift the camera. Okay. Okay. I'll lift it. Now, further go down. Okay, okay. Okay, now. Yes. Now fully visible. What all I wrote now? Fully visible. No, what all I wrote. Now fully visible. No, what all I wrote. Fully visible now. Okay. Now, this is middle one third. Now, load is anywhere here. Load is anywhere on this line. How? Perpendicular. Now, if the load P is acting along 1, 1, you should write a note. I will tell the point as A, B, C, D, E, F. I think I took E, F. A, B, C, D. I will tell E, F. Here, once again A, B, C, D. I don't remember now. I will put F, G here. F, G here, middle one third. If the P is along 1, 1, that is anywhere in middle one third of S1. One third of S1. Here, load along P along 2, 2, that is anywhere in middle one third of S2. In that case, in this case, then there will be no tension. No tension if column cross section considered. If column cross section considered. If column cross section considered, no tension. Whereas, tell what you have tell. If it is a foundation part, if it is not a column section, it is a contact of footing with soil, then what you have tell? Tell me. Then what you have tell? Not no tension. What is the correct word? If it is a column section, okay, no tension. But if it is a footing contact area, then I am coming to that one now. If it is footing contact area, see this way, this is the cross section where load is acting here. So if it is footing contact, then we don't call no tension. Why? Footing cannot take tension. Contact area cannot take tension. No. Which is not there? Here, where is what? Column cross section, there is no tension, only compression. You can write here. No tension or only compression. Only compression. Here. Whereas, I use the word, you can tell no, whereas it will be what? No lifting if footing considered. Footing considered. No lifting means everywhere what? Soil will be pressed down. Pressed down. Everywhere soil will be pressed down. Here, everywhere cross section is compressed. Clear now? That is the condition. Now, this is actually called what? Remember now, this is actually called uniaxial. Uniaxial. This also is called uniaxial. Uniaxial. Okay, now consider biaxial. Now consider biaxial. That is eccentricity E with respect to both 1, 1 and 2, 2. Both 1, 1 and 2, 2. Biaxial. This already over earlier. Then for no tension in case of column cross section or for no lifting in case of footing In case of footing, tell the condition. Footing, I will put sketch here. See, then continued further. Statement continued. See, what you do is, see, this is your S1. This is your S2. Divide. This is the axis. These are the axis. Okay, over. From here, 1/3, 1/6 of S1. Here, 1/6 of S1. See, I write here now. This cut are S1 by 6. S1 by 6. The total is how much? Total is S1 by 3. Same way here. Little more. Okay. Here. This way. This is what? S2 by 6. This is S2 by 6. The total is S2 by 3. S2 by 3. Mark this way. See. This is. Now, for no tension in case of column cross section or no lifting in case of footing, this is a sketch. Continue the statement. See, statement continued. Statement continued. Where? I will write here. If it is visible. If space is there, I can shift the S1 upper side. Okay. S1, I can shift upper side. Okay. Now, if space is there, I will write here. If space is there. Load should be somewhere in shaded portion. Shaded portion. Clear? If the load is somewhere in the shaded portion, see, if it is here, okay. If it is here, okay. Here also, okay. See, here it is uniaxial. Here it is uniaxial. Somewhere here means biaxial. It can't come here. It should be somewhere in the shaded portion, which is called core. Some people call core or kern. Kern. It should be in that core area. The core area means it is this, not this shape. If you make this shape, what will happen? Double accelerative will come. Gone case. See, you join these 4 points. Load should be anywhere. It can be anywhere in the shaded area. And now write, note a note. In case the load leaves the shaded area, if it comes here, 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 or here, if it comes this side, then this will lift. You should write. If it goes this way, this will lift. If it comes this side, this will lift. If it goes this way, this will lift. So load should be within this shaded area, which is called kern, or some people call core. Fully clear? That's all. So that kern will be a diamond shaped one where the 2 diagonals are 1/3, 1/3. See, you mark 1/3 total length or send CG. Mark 1/6 this side, 1/6 this side. Mark 1/6 this side, 1/6 this side. Join it. Load should be there. Clear? Okay. Furthermore, not required. It will come when you go for application. Okay. Now, this is for rectangular section. I will just explain for you circular section. Briefly, sufficient. Further, standard is rectangular or circle. Okay. Furthermore are there? Not required. Circular section. Now, 1 minute. Remember, make a note. 1 minute now. I will write here. Then I will go for application. Very important application. See, this I will remove now. Go through the again. Now see. Consider circular cross section. Circular cross. Standard case. Circular cross section. Make a note. Make a note. For rectangular section, we got E equal to once S1 by 6 or S2 by 6 for what? That is the limiting. This is limiting E. Limiting E for no tension. For no tension. By equating, which one tell me? By equating P by A to M by Z. Yes or no? or that is why, that is because your P by A minus M by Z equal to 0. Tell me, remember or not? P by A minus M by Z equal to 0. Tell me, yes or no? P by A minus M by Z equal to 0. Now, if it is circular section, see, let the diameter is D. Within 1 minute over now, D, over, D. Now see, this is the axis. Consider load anywhere here. Or here, it can be anywhere. It can be here or here, but within the limit, but little inside. Okay, then your area equal to pi by 4 of diameter square. Then I equal to pi d power 4 by 64. And y maximum equal to d by 2. From the any axis to extreme fiber d by 2, which will give z equal to pi d power 4 by 64 divided by d by 2, or z for circular section is pi d cube by 32. Okay, now what you do is, once again same thing, again same theory. Now we can't waste time. Same story once again. Okay, therefore what? For P by A minus M by Z equal to 0, that is what? Resultant test 0. P by A equal to M by Z. P by A pi d square by 4 equal to M is P into E divided by pi d cube by 32. P will cancel, pi will cancel. Then or what will happen? This d cube will go to denominator, will come to numerator here. D cube by d square is d. Then 32 here denominator will jump to numerator. Then from numerator it will come denominator here. 4 will go to numerator. That is d should be what? Tell me. D should be equal to, not d. Your E will be equal to d by, how much? Tell me. E will be equal to, answer, d by. There you got S by 6. In rectangle section you got 1/6 eccentricity. Now tell me answer. In rectangle section we got S by 6. D by 8. Over. That is, you can write, you write, load should not go this way beyond D by 8. Load should not go this way from here beyond D by 8. Should not go this way beyond, same way, D by 8. Should not go this way also by D by 8. Or you can conclude now, too much story is not required. Why? No point in wasting time. Or for no tension, the load should be, see, if it is circular section, you write one more circle here. This way. Tell me. Full diameter is D. Can you tell the diameter of this one? Tell me. This is D by 8. This is D by 8. If it is D by 8, this is D by 8. Little smaller. Okay, this way. If it is D by 8 here, D by 8 here, tell this diameter. This diameter. This is the core or kern. So core or kern will be circular of diameter equal to, tell correctly, see, from center, D by 8, D by 8, D by 8, D by 8, see here, this is from center, D by 8, D by 8, here also, from center, D by 8, D by 8, so this should be a circle of diameter, how much? D by 4. D by 4. So remember, rectangular section 1 by 3 of side. The core or kern will be whatever is the dimension considered, middle 1/3. Here, in the middle 1/4. Clear now? Middle 1/4 portion. For circular section, not 1/3. See, rectangle, middle 1/3 means eccentricity is 1 by 6. Same way here. 1 by 4 means it is the total. Eccentricity is what? D by 6, D by 8. Fully clear? So I won't waste time. I'll go further now. Full clear means I'll go further. No point in wasting time. Everything is explained thoroughly. There is nothing to be explained further. That class still pending. I will upload within 1 or 2 days. But only for public. You don't have to worry because unlisted class is available for you. You can study it. I told one S1, S2 problem. Some of you told actually, sir, no problem, leave it. People understand. No, but still, I don't like it. Okay, now, one very important note. Make a note here. Note. When we consider column cross section, then P by A plus or minus M by Z. P by A plus or minus M by Z, that is for uniaxial. Or P by A plus or minus, I wrote earlier, My by Iy into X plus Mx by Ix into Y. I wrote X and Y there. This is for biaxial. Remember now, make a note here. Note, this X and Y we will replace by 1, 1 and 2, 2 little later to understand correctly. I will tell the reason for you. Okay. Because of avoiding confusion for column, RCC column. This formula, column, these expressions, if it is uniaxial, P by A plus or minus M by Z. Biaxial, P by A plus or minus My by Iy into X. Biaxial. That is what? This is for what? Actually, P by A plus or minus M by I into Y for uniaxial. Okay. This is for what? This is column. Then these expressions are for finding resultant stresses. Our sign is compression positive. Okay. Then resultant stresses. Over. Now, and for extreme fibers, this expression will change over to expressions will reduce to what? Reduce to P by A plus or minus M by I into Y not required, I by Y is Z, M by Z for uniaxial and or other is P by A plus or minus M1 by Z1 plus or minus M2 by Z2. This is for biaxial. Fully clear? If you want, this is general. Anywhere. General sigma anywhere. This is for sigma resultant anywhere. This is for sigma resultant at extreme fibers. Full clear? This all discussed earlier. I won't waste time now. Okay, start. Now, this is for column. Now we will tell goodbye to column. Right? Now, goodbye to column cross section. Consider footing. Footing can be either for RC column or for steel column. If it is steel column also, see, in the steel column, first column will be placed on base plate. Then the contact is from steel plate with concrete pedestal. Later, pedestal to soil. Too much will not go. Or what? retaining wall, or dams, dams, anything. Now, then tell the answer. The contact area will become cross section for P and M. See, correct, clear. Load is this way. This is the cross. See, when the load is this way, cross section is perpendicular load. In case of column, when you apply load this way, column cross section. When you consider footing, see, when you take footing, when you apply load this way, this is the cross section. How? Or remember, that is what? That is, cross section is what? Tell me. Plan front view or side view. For a vertical member, if the load is applied this way, moment will come this way or this way. When you apply load this way, the cross section, that is the contact area, see, the contact area, cross section, will it be plan area, front view area, or side view area? It is plan area. I won't tell once again. Plan area. Okay, now, and note, here, the term compression means what? Here, the term compression, you write here, the term compression used earlier corresponds to what? Tell me. Corresponds to what? Tell me. The side term compression, there it is compressive stress. Here what? The term compression corresponds to what? Corresponds to what? Not stress actually. When you consider contact with soil, compression means what? It is not stress actually. It is called what? You know it. The term compression, what you used? The term compression means corresponds to what? Soil being pressed. Soil being pressed down. Therefore, what? Tell me. Soil is being pressed down. So, what reaction will come? Tell me. If the soil is pressed down, what reaction will come? Upward or downward? The reaction from soil on the footing slab, contact area, pressure will be up or down. See, this way, it should be compression, upward, down. Therefore, from soil, there will be upward pressure on footing slab, upward pressure on footing. Tell me, one small note, good or bad? If the pressure is upward, good or bad? Tell me. Suppose stability point of view, soil, it is pressing the soil. So you should remember, good or bad? Good. Why? Stability. It is good. I won't tell once again. Good. And, right. And second term. The term tension used earlier corresponds to what? Corresponds to what? Compression means soil is pressed down. Tension means corresponds to lifting. In which case pressure should be down. See, down. If you press down, if it presses here, pressure is up. If you lift here, pressure is down. But soil cannot offer what pressure? Tell me. Suppose you stand here. See, if I lean this way, I will be pressing. You write all these things. Suppose I lean this way, I will be pressing the soil. Yes, soil will give reaction. Other side, lifting will come. Will the soil will give downward pressure, downward resistance? Will it give? Will the soil will give downward resistance? No. Will the soil will give you downward resistance? See, when it is lifted here, soil has to pull you down. Will it pull you down? No. But only pulling down will come in steel, write it, when base plate is provided with anchor bolt. That you worry later. So under normal case, lifting means actually tension means lifting. Soil, but soil cannot offer what? Offer resistance to lifting, for lifting. Therefore, see now, one thing forgotten here, compression means plus for us. Compression means positive. Tension means what? Therefore, tension, sign we use is negative. Sign negative. Therefore, tell what? Lifting. Good or bad? Suppose an edge gets lifted, stability point of view, good or bad? Tell me. Suppose it gets lifted, good or bad? Good or bad? I am taking class in simple language so that I can go to technically any level. But let the people understand correctly. It is bad. Right here. Bad. Therefore, what? There should be what? There should be no lifting. No lifting. No lifting. This designer should ensure by providing suitable cross-sectional area in plan. By providing suitable cross-sectional area in plan. Clear now? Now you can do one thing. Now you go to RCC. Actually, in the which one YouTube earlier RCC, I explained in the YouTube class only how to decide that S1, S2, so that lifting is prevented. And one more thing, one side pressure will come upward, soil will press the soil. The maximum pressure will come. That should not exceed SBC of soil. Remember? Yes or no? The maximum pressure where full compression comes, that should not exceed SBC of soil, and other side lifting to be avoided. Tell me, remember or not? You can go to my RCC class available in YouTube and study. Those who are outside, those who want, they will study. For you, it is already over. Okay, now, what I will do is, now remember now onwards, when you consider the contact area, cross-section to be considered is the plan area, this area. I will do one thing now. First, I will go for, we will consider uniaxial case. That is P with M about only one axis. Tell me, very, very important. You write a note here. Important for, not for RCC column. RCC column, it will be always P with the M1, M2. I will give full sketch of that one. Once this is over, first I will finish this one. RCC, it is what? P, M1, M2. Tell me, P with only one M. Where? Tell me. Very important. Tell where required. First, P with only one M about only one axis. Very time pass I will not do. Very important. Tell me, in case of which one? Axial force with only one BM, only about one axis. Still Allah. Footing M, no. Column footing means it is load with biaxial. Think in it and tell me. P with only one, no moment the other way. Only one way. Retaining wall. It is for retaining wall or dams. Masonry dams. Okay, now, first I will take actually first one example, and then very systematically we will consider what? Footing for RC slab, footing for RC column. Full principle I will give you. First do one thing, understand one uniaxial. See, first, I will give example for you now. See, example. A masonry dam, spelling problem, okay. A masonry dam is having a height of say something like 7.5 meter. Okay. 7.5 meter, 7 point masonry height, quite normal height. Then top width is such that sometime vehicle can go, sometime vehicle cannot go. If vehicle goes, sometime it is advantageous. Anybody can tell? If it should not go at the edges, if a heavily loaded vehicle goes, it is an advantage sometime. To what? Not pressure, for controlling the lifting. We won't consider that one. Top width is 2.5 meter and bottom width is 2.5, 4.25 meter. 4.1 meter, 4.25, 1.5, 1.75. 4.2.5 plus 1.8. 4.3 meter. Okay, just to avoid changes. 4.3 meter. Next, weight density of masonry is stone masonry. It is a stone masonry is 22 kilonewton per meter cube. That's all. Consider water for full height. No freeboard. If freeboard is there, anyway, design purpose full height. Because why? As the water pressure, water height increases, it will affect the stability. Even if freeboard little gap is there, when you check, you should take full height of water. Okay, now that's all. No further. See, correctly, this is a masonry dam. See, I will put the sketch here now. Now see, this is the masonry dam. And one more thing forgotten. Water side is vertical. I can take incline. No. There is a limit in the class. This is not RCC class. This is the masonry dam. See, cross section. This is a cross or 1 meter. We put 3D sketch. 3D sketch is this way. See, it's a masonry dam. This is the base. It goes this way. It goes this way here. This top width is 2.5 meter. Bottom width is 4.2 meter. The full height is this is 7.5 meter. It goes this way. Tell me. Now, where is water? Tell me here. Where is water? This is water here. See? This is water here. It continues. Water is here. This masonry dam continues here. Water. Now, you should know one thing. Consider, anybody can tell, for analysis purpose, anybody can tell, consider, you should know it. You should know it. When you consider retaining, not for footings, RC footing, when you consider a retaining wall or dam running lengthwise, we do not know how much is this length. It can be for 1 kilometer also. It can be for 1 kilometer also. But you should know that one. Consider what? First, consider 1 meter length. 1 meter length as shown. As shown. See, you are considering somewhere this way 1 meter. Tell me, this way 1 meter, clear or not? It is a standard case. Clear? You are considering 1 meter this way. That is, for this cross section, this along the length of wall, 1 meter. Full clear? First. 1 meter is this way. You cannot see it now. Clear? Okay. Now, I want the values here. This will be there. Data 22 I have given. Okay, sufficient. Further is not required. See now, correctly see now how is the arrangement. Consider contact area, contact of dam with soil. With soil. See, now remember, you have to consider plan, very important, plan. The plan will be like this. See, not here. Plan where? Tell me. At the top or bottom? Plan. Plan at top or bottom? First. Plan at top or bottom? Contact area is the plan at top or bottom? 4.3, 4.3, okay, 4.3, okay. Tell me where? The plan take contact area is the plan. That is the cross section. Where? Bottom or top? For pressure calculation, bottom. Plan at bottom. See, if I take plan at bottom, what you can see? Tell me. See here. You are cutting here and looking from this side. Therefore, tell me what is this length? First tell me. This length. This is the chord. See, you are seeing from front here. This way you are taking what? See, you cut here and look from top. Then cut here and look from top. Then tell me how much is this length? This length. Oh, see, masonry wall is going this way. You look from top here. So what is this length? First. What is this length? No. What is this length? Looking from top, this length. Length I want. I want length here. Looking from top, you can turn the sketch. It's 1 meter. 1 meter is this way. See, it is going this way. See, at the base, see, this way. You look from top, cut here, look from top. This is 4.3 meter. People call this as B, remember? But it is actually, this is very popularly called B, that is base width. Base width. It is not structural B. It is not structural B, simply base width. And this will be 1 meter. 1 meter. See, now, tell me, here, first you calculate loads. How? See, now I will first calculate loads coming and other things. Leave as it is, see now. Now, this is the axis to be considered. See, this all moment or BM for the base will come this way and this way. Clear or not? See, due to load, if it is eccentric load, eccentricity is along 4.3, and if it is a water pressure, it will topple like this. So, this 4.3 meter will become structural what? Tell me. This 4.3 will become structural what? See, load this way will come. Any overturning moment or which one? Due to eccentricity, if anything happens, effect is not this way. Effect is this way. See, when the dam is here, when you see the dam going here, effect is this way. So this 4.3 meter is called what? Structural. Structural depth. It is structural depth. So symbol is B, and this 1 meter is called structural width. Structural width. Therefore, structural calculation point of view, tell the answer, B equal to 1 meter and D equal to your B, base width. This B is not width B. standard base width B, or I'll do one thing now. I'll call B, or to confuse, avoid, I'll put B naught. Okay. This is B naught equal to 4.3 meter. Fully clear? This is the axis. There is no XXYY. This is the axis considered. Axis considered. That's all. Don't call XXYY all. Full clear is okay. Now I should calculate loads. See now. Let's see. When I calculate loads, first I will calculate vertical loading. See, I will remove the sketch. When I take vertical loading, this weight has got one rectangle, one triangle. You cannot take trapezium, because if you take trapezium, CG formula is this way. This way, no CG formula. If you apply CG formula for trapezium, it is applicable only for CG measured from one of the parallel sides. But we want center of gravity this way. So formula not possible. See, I will take the sketch here now. First consider weight of dam. Weight of dam. Remember, for 1 meter length, cross section is like this. This is the cross section. See here. Now 1 minute. This is the cross section. Put dotted line. This is how much I told? 2.5 meter. Total width is how much? Total width is 4.3 meter. Therefore, what is this width? 1.8 meter. See, there is one weight here down. One more weight here down. Little bigger sketch I'll put so that it will be fully clear. Little bigger sketch. Okay. More. Okay, now clear. This is 2.5 meter. This is 1.8 meter. See, I'll put everything here. This is 2.5 meter. Total width is 4.3 meter. So this is 1.8 meters. Okay, out of scale. This you take one of the load down. Other load is acting here. This is one, other two. I will call this as W1 and W2. Anybody can tell where W1 is acting from here? Fast. See, this way is 1 meter. Remember now, this way is 1 meter. Where W1 will act from here? Fast. Anybody can tell where W1 will act? 2.5 by 2. This will be 2.5 by 2 meter. Where W2 will act, this distance, 1 by 3 or 2 by 3. Fast, from here. 1 by 3 or 2 by 3. Okay, equal to 1.25 meter. Okay. This is 1 by 3 of 1.8 equal to 0.6 meter. Fully clear? Okay, now correctly calculate W1 and W2. W1 and W2. Remember, note, weight of water will not come, pressure will come later. Note, weight equal to volume into density. Volume into weight density. If you are not knowing, better not continue my course. This is the PUC level, high school level. Volume into weight density. So, weight density for dam material, masonry dam, which one? Earth masonry, given as 22 kilonewton per meter cube. Therefore, your W1 equal to volume 2.5. Oh, full height I forgot right here. Full height, how much I told? 6, 7. Who remember the full? No, it is not there. What is the full height told? Full height told. Forgot. Some 7 or 6 point something I told. Full height given. You are not giving answer. 7.5. Okay. 7.1. 7.5. 7.5. So your W1 equal to 2.5 into 7.5. This will give cross-sectional area. Actually, if you remember RCC, That's all. One more into is not required. When you calculate weight per meter length, weight equal to only area into density. Remember, see, RCC, weight of beam, 200 by 500. What you do? 0.2 into 0.5 into 25. Why? That is the weight in kilonewton per meter. But anyway, just to understand, into 1. 1 you cannot see. Into 22. Tell the answer. W1 will come in kilonewton. If you don't write 1, it will come in kilonewton per meter length. Here, everything is per meter length. It will come in kilonewton. Actually, remember, it is kilonewton. These are for 1 meter length. These both the values are for 1 meter length. Answer. Answer. W1. 412.5. Sudal Bardu. 412.5 is the answer. And tell me W2 value. W2. Area. Half into 1.8 into half into 1.8 into 7.5 is the area into length is 1 multiplied by 22. What is the answer here? This area intensity here. Half into 1.8 into 7.5 is the area into length is 1. Answer. W2 comes in kilonewton, but for 1 meter length, it is 148.5. Tell me, where these two loads will act? If I take length, this way correct, this way it is here. If I take lengthwise, where this will act? First, tell me, distance. If I take this way, correct, see, it will be this way. Suppose I consider this way. I took 1 meter length. At what distance from the face here? If I go inside by 1 meter, this way, at what length? 0.5 meter. So, that will be acting somewhere. See, two loads are there. I will put the two loads here. See, your W1 is acting here, 1 meter. W1 is acting here, along this line, center line. Why? It is 1 meter means these are 0.5. See, these are 0.5. It is passing to center. And see, now this is your W1. W2 is acting here. Therefore, tell me what is this distance and what is this distance. Tell me. This distance is, see, this is how much, like you write one more sketch. Not use the previous sketch. Write one more sketch here. W1 is acting at distance from there. This is 1.25 meter. See, this is 1.25 meter. So, tell this distance first. From 2.5, this is 4.3 meter. This is what? Each of that is 2.15 meter. This also 2.15 meter. Tell me this distance. 3.1 meter. 3.1 now. From center of gravity axis. 3.1 now. This is 2 mid from the center. See, from the center here. This is 2 when this is 4.3, 2.15, 2.15. This is 1.25. How much is this one? 3.1. If you give this way, how to solve the class? This is 2.15, 2.15. Why? Axis comes here. See, if I see centroidal axis here, 0.9 meter. It was that back. 0.9 meter. Okay. Now, W2, where acting here? 1 minute now. Before that, we do one thing. W1 is actually, I'll put here now. You draw one more sketch now. Or it is here. This is your W1. W1 is acting at what distance from there? 1.25 meter from there. 1.25. So this is 0.9 meter calculated. Now, W2, you do one thing. For W2, values I'll put later. W1 is 412.5. W2 is 148.5. So that volume came. Okay. Now I will remove those two. I require the space. Now you make one more note there. Right. One more note. Tell me W2 distance from here. This is 4.3 meter. Tell me W2 distance, or you can do one thing. Tell W2 distance from here. What is this distance? Directly you can tell. If it is 1 by 3, what is 1? This will be 2 by 3 of 1.8. How much? If it is 1 by 3, this is 2 from this edge. 2/3 of 1.8. 1.2 meter. Therefore, this is 2.15. W2 will act somewhere here. W2. That will be acting from here at 1.2 meter. If that is 1.2 meter, tell this distance. If that is 1.2 meter, tell this distance. That distance. This is total 2.15. This is 1.2. Where is W2 from the axis? Where is W2 from the axis? 0.95 meter. Correct? 0.95 meter. Okay. Now, therefore, I'll write here now. Therefore, or you write here only. Now I can remove that one. I can remove that one now. Why? Everything is over. Shall I remove this one now? Shall I remove this one? Tell me. Shall I remove that one? So that distance are over now. Don't make any mistake. Shall I remove that one? Oh, 46 for 0. Playing like tigers today. Playing like tigers. By the time class over, match will be over. Shall I remove that one? See, you are not answering. Can I remove that sketch? You are not answered. So that it won't come once again. You practice after the class. If you don't answer, yes. Therefore, this I will remove. Now, very important now. Therefore, now I will write here. This will be equal to cross section like this. This is the axis. W1 is here, W2 is here. Here, point load of W1 plus W2 here. And W1 into 0.9 is this way the moment. A moment this way of W1 into 0.9 and a moment this way of W2 into 0.95. Tell the answer. W1 into this is W1 into 0.9. See here, about this point, W1 this way, W1 into 0.9 this way, W2 into 0.95 this way. Tell the answer. W1 into 0.9 how much? W2 into 0.9 how much? After another 5 minutes, problem will come back to you once again. Answer. W1 how much you told? W1 is 412.5 into 0.9. W1 is 412.5 into 0.9. What is the answer? 371.25. And this is W2 is 148.5. W2 is 148.5. Answer. 3 is this one equal to W2 148.5 into how much? It is answer 0.95. 141.075 kilonewton meter. Now, remember, still not over. Tell what is lastly pending. Tell what is lastly pending. So, for the base contact, there is a vertical force downward of W1 plus W2. Remember, W1 plus W2 will be equal to 412.5 plus 148.5. Tell this answer also. 412.5 plus 148.5. Answer. 412.5 plus 148.5. How much answer? 412.5 plus 148.5. 561 kilonewton. Okay. Now, therefore, at present, the effect is, I will write here now, effect is, if I take axis here, there is an axial load of 561 kilonewton perpendicular, and tell the answer here, 371.25 this way, 141.075 this way. Answer, 371.25 this way, 141.075 this way. Net answer. It will be surely like this. How much? At present answer. This is due to what? Due to masonry wall. Due to masonry wall. 560. Answer. 371.25 this way, 141.075 this way. 230.175 this way. Over. Tell me. Right? Not over. Not over. Tell what is still pending. Not over. Tell me still what is pending. Still not over. What is still pending? Everything is not over now. One most critical is pending. One critical is pending. What? It is not over. Critical is pending. Fast. No, it is not ready for calculation now. Not for pressure calculation. What is pending? If you tell that way, area. Abba. What is pending means area now. Abba. What is this? Next, I will remove this one now. See, if possible tomorrow, I will tell it in other way how you do in RCC. Shall I? How we perform in stability analysis in RCC. If you want tomorrow, 15 minutes I will tell, so that you can go that way also. This is with the basic principle. In RCC, direct procedure. There, simply procedure. Here, basic principle. Do you want it? Do you want or not? Tomorrow's class, or 15 minutes. How you do in RCC part, this one. When you retaining what you considered, how you consider this one RCC? No, do you want or not tomorrow? Tell me. I want. Tomorrow I will tell. Today, pakka basic. See, to RCC, I usually give steps to the class. Find this way. I will tell the steps for you. Finally, same. Now, lastly, most important, water pressure. Water pressure. See. Remember, this is not fluid mechanics class. This is the wall. This is water. Height is 7.5 meter. Water pressure will come this way. Now, I will put here. So, therefore, this is 7.5 meter. Therefore, for this one, there will be water pressure like this. Water pressure will act here. This pressure is 9.81 into 7.5. Answer. Fast. Sorry. Somehow you learn yourself only. Some people take 10. I will take 9.75. Fully clear? Tell fast. 9.81 into 7.5 is the water pressure in kilonewton per meter square. Clear? If clear, tell clear. Or go to fluid mechanics, study and come back. 73 point, how much? 58. Tell me clear or not? 73.575. I Allu Chaukasi. 73.575. You tell me clear or not? Sorry. Now these all I can't explain here. Clear? Okay, done. Now this will give a lateral pressure resultant force here. See, this is resultant resultant force due to water pressure. Water pressure for 1 meter length of retaining wall. Length of retaining wall equal to, you should know one thing, today only write, whenever a pressure diagram given, either pressure, soil pressure diagram or water pressure diagram or pressure diagram on footing, then if you consider 1 meter length, how? In the direction, not this way. How is the pressure acting? If you consider 1 meter length, then this pressure resultant force is always equal to area of pressure diagram. Pressure diagram. Sorry, there is a limit for explaining here. Remember it? But remember, only when you consider 1 meter length, resultant force equal to area of the pressure diagram. Clear or not clear? Or see correctly, I will tell you why. See, 1 minute. Those who want. Average pressure 0 plus 73.575 divided by 2. Average pressure is what? Is 0 plus 73.575 divided by 2. Into contact area is 7.5 into 1, or half into 7.5 into 73.575 is nothing but area of pressure diagram only. Or remember, whenever a pressure diagram considered, if you consider 1 meter length, how? Which is perpendicular to pressure diagram, not this way 1 meter, this contact this way, then in case of retaining wall, in case of dams, in case of RCC footing, in case of steel, anywhere, if you in the steel you take 1 mm strip. Why? Because their pressure is in Newton per mm square. In watt unit you write pressure, that linear. If you take 1 unit length, then resultant force is always equal to area of pressure diagram. Tell me, fully clear or not? Fully clear or not? Resultant force is always equal to area of the pressure diagram. One clear required for me. Area of the pressure diagram. Why? Because 0 plus 73.575 divided by 2 is the average pressure into this area. How much? 7.5 into 1. Okay. Now, there is a limit here. Or, therefore, equal to, tell the answer, half into 73.575 into 7.5 will give the value in kilonewton. I am going this way. Answer. Kilonewton for 1 meter length. Answer. Half into 73.5 into 0.575. Fast answer. Tomorrow I will give you easiest way. This is called basic calculation. Systematic calculation, this is called. Those who find difficulty, tomorrow 15 minutes, I will write the way we do in RCC. Then you will tell, sir, this is fully clear. Why? That we are doing in RCC B. 275.906. This is 275.906 kilonewton, which will act at 1 by 3 of 7.5 equal to 2.5 meter. Therefore, now do one thing. Therefore, now this water pressure for the contact area will give a force like this of resultant force 275.906 kilonewton, and also what? And also a overturning moment this way of 275.906 into 2.5. Answer. Into 2.5. Answer. 275.906 into 2.5. Answer. This will give this way moment. 275.906 into 2.5. Answer first. See, actually, first of all, is tensometers. I need not take dams. I decided when you learn, at least learn one systematically. 689.765 kilonewton. Now, kilonewton meter. Now, this should be considered along with this one, which is already over. Along with this one, this also should be considered. Now, tell me, this right here, this 275.906 will not cause pressure. This will be late, this will be considered for, anybody can tell? This 275.7906 will be considered for, anybody can tell the answer? Those who want. This force, when you transfer here, the couple will come. That couple will be considered. That, see, this way moment. 275.906, that will try to shear, or it will be considered for what? Tell me. Anybody can tell? This lateral force. See, force is acting here. When you transfer here, force with the moment. Moment considered here. That force will be considered for sliding. When you check for sliding, at that time you have to consider it. At the time of check for sliding, then you calculate resultant vertical load, then coefficient of friction into resultant vertical load will give you maximum frictional resistance that can be developed. You have to compare it with the sliding force. Then you have to find factor of safety. Usually a safety margin of around 1.5 required. If the sliding force is 100, resisting force should be at least 150. That all we are not discussing here. Our chapter is combined stresses. That I discussed in retaining wall. Remember, when I did RCC retaining wall, that all I considered. People remember it? Retaining wall long back. Do you remember those who are in RCC batch? Remember it? Check for sliding. And if unsafe, how to provide shear key? No. If it becomes unsafe in sliding, you have to provide a shear key. This all I told him, yes, here not required. Therefore, see, last step now. Therefore, conclusion today. Therefore, conclusion. Antima tirmana, conclusion. For the cross section, that is in plan area, this is the cross section considered for 1 meter length of retaining wall. Don't write this way 1 meter, not required for us. This is 1 meter. Why? And then this is total is 4.3 meter. That is your B naught. That this 1 meter will be structural B. This B is the structural B. And this will become structural D. Why structural D? Axis is this way. Why this way means, see, this way moment. There is an axial force I will call P, and tell me, there is an axial load P. Tell me P value. That P value is nothing but your W1 plus W2. Answer, 561 kilonewton. And there is a net momentum, see, 230.175 this way and 689.765 this way. You combine these two, surely like this, a single moment M of, tell the answer. I will call ABCD. Okay, once again, back to square A. M. Already due to masonry weight, it is actually what? Resultant is that side. It is coming what? 230.175 that way. And water pressure will give moment of how much? 689.765 this way. Net answer. Final answer. Answer. Final answer. Single moment. This sketch I will not remove. It will be there. 400 and ಎಷ್ಟು 459.59 kilonewton meter. M is, I'll put M only, M, okay, M equal to 450, 450, mobile, 259.59 kilonewton meter. Everything is considering 1 meter length of dam. Now ready for pressure calculation. Now if you cannot calculate pressure, see, I will call A, B, C, D. Now do one thing now. You tell me what is the, now I should not explain. Now I need what is the resultant pressure along which edge? Along AD. I want answer in Kn per meter square and also ABCD. What is the resultant pressure along BC edge? Both in kilonewton per meter square I want. Okay, get the answer if possible. Tell now only, because I will go to alternative approach, then I will do it. Actually, you can do it. I will calculate. Tell me whether you got or not. I just want to know whether you got or not. I am getting here 279.602 here and there. Here I am getting plus I am getting, there I am getting plus, not plus actually. I am getting minus 18.671. That means, I will explain tomorrow, this retaining wall, the base width provided is sufficient or not sufficient. Tell me, negative sign came there. Negative sign means that side will get lifted. So conclusion today, for this masonry dam, when top width is 2.5, for a height of 7.5 meter, what base width they are given? See, the most critical is the base width. You give more and more base width, more and more stable. So the base width of 4.3 provided is sufficient or not sufficient? Tell me, is sufficient or not sufficient? Is sufficient or not sufficient? That's all strength of materials. What to do? RCC, you know, increase the base width. Tell me, one side, see, now we do not know what is the SBC of soil. Maximum pressure came 279. If SBC of soil is around 200, 250, it is unsafe on pressure. And that side, negative pressure came. So, tell me, these all tomorrow you will be knowing by systematic way, calculate resultant E, we will compare E with B by 6, 1/6 the length. That will tell you what? Pressure is, negative pressure will come. Tell me now. The base width provided is sufficient or not? I want. The base width provided for this example is randomly given. Sufficient or not? Most probably, SBC also unsafe. Why? 279 is too high pressure. You are not answering. Fast. Don't worry about maximum pressure. Who knows? SBC can be 300. Whatever is that one. Negative came. The base width provided is not sufficient. Okay, that. Then you have to increase the base width and once again try it later. That all not our problem. Tomorrow I will tell you how to do this systematically like RCC. If you want, I will tell me 15-20 minutes. It will take, you can make a note. So in later practically, you don't have to struggle all this way. Systematic, easy method is there. Very simple method is there. That way, finally remember, there also answer will come same. If you want, tell me. If you do not want, I will close that part, go to final foundation result and stop the class. If you want, tell me. I should write before start, if possible, little. If you do not want, oh no sir, we can understand it, leave it. You want or not? This much calculation can be easily understood by a simple procedure. You can make a note. It is valid for retaining wall, valid for dams, everywhere. Footing not valid. You are not answering. No answer, whether you want it or not. Okay. I will decide if got it. No. You want or not means got it, sir, means okay. Not pressure. Instead of struggling all this way, a simple method is there. Okay. Tomorrow I will tell. It will take 15-20 minutes, that's all. Okay. Tomorrow I will give that one. Then go to the closing part of foundation, that M1 by Z, the last part of the footing slab, biaxial, load the biaxial, and this chapter will be over. Okay, thank you. I have taken no break also today. I suddenly remembered, break not taken. Okay, I will close now.